Building on our knowledge of data structures, we'll explore how Python interacts with external data through input and output operations. I/O operations are fundamental for working with files, handling user input, and processing data. This knowledge is essential for creating practical applications that can persist data and interact with users. Today's lesson builds directly on our previous work with data structures and control flow. We'll learn how to persist and retrieve data, crucial skills for building real applications. Understanding I/O operations will allow us to create programs that can read configuration files, process data files, and interact with users effectively. The open function is fundamental to file operations in Python. Notice the two approaches shown, the traditional open read-close pattern and the context manager, with statement. The context manager is preferred as it automatically handles file closing, even if errors occur. File modes determine how we can interact with the file, reading, writing, or both. Python offers several methods for reading files, each suited to different needs. Read is good for small files, while reading line by line is memory efficient for large files. Read lines is useful when you need to process all lines but want them in a list. Remember that read loads the entire file into memory, which might not be suitable for very large files. When writing files, the mode W versus A is crucial. W mode overwrites the entire file, while A adds to the end. Notice that write doesn't automatically add new lines, you need to include \n explicitly. Write lines is convenient for writing multiple lines, but also doesn't add new lines automatically. Be careful with W mode as it will erase existing content. CSV, comma-separated values, is a common format for data files. Python's CSV module provides powerful tools for handling CSV files. The dictreader is particularly useful as it returns each row as a dictionary, using the header row for keys. Note the new line equals parameter, this ensures consistent handling of new lines across different platforms. Writing CSV files can be done with either writer or dictwriter, depending on your data structure. Writer.writeRows is efficient for writing multiple rows at once. Dictwriter is particularly useful when working with dictionaries and ensures consistent column ordering. Always specify the field names when using dictwriter to control the CSV structure. JSON is a popular data format for configuration files and API responses. Python's JSON module makes it easy to work with JSON data. Notice the difference between load, for files, and loads, for strings. JSON data is converted to Python dictionaries and lists, making it easy to work with using our existing knowledge of data structures. When writing JSON, dump writes to a file while dumps creates a string. The indent parameter creates formatted, human-readable JSON. Python data types are automatically converted to their JSON equivalents, e.g., true becomes true. The JSON module handles the conversion between Python and JSON data types seamlessly. Error handling is crucial for robust I/O operations. Files might not exist, permissions might be insufficient, or encoding issues might arise. Always use try-except blocks when working with files. Common errors include file not found error, permission error, and Unicode decode error. Good error handling makes your programs more reliable and user-friendly. The pathlib module provides an object-oriented interface to file system paths. It's more powerful and readable than os.path. Path objects can be combined using the / operator, making path manipulation intuitive. The glob method is useful for finding files matching patterns. Always use pathlib for modern Python path manipulation. Binary file operations are used for non-text files like images or executable files. Use RB and WB modes for binary reading and writing. Reading in chunks is important for large files to manage memory usage. Binary data is returned as bytes objects, which are immutable sequences of bytes. User input requires careful validation to ensure data quality. Always assume users might enter invalid data and handle it gracefully. The while true pattern with try except is common for input validation. For multi-line input, collect lines until a condition is met, like an empty line. The combination of pathlib and shutil provides powerful tools for file system operations. Always check if files/directories exist before operations. Use shutil for high-level operations like copying. The reglob method is great for recursive file searching. Remember to handle permissions and file existence errors. Following these best practices ensures robust and maintainable I/O operations. Context managers prevent resource leaks. Error handling makes programs reliable. Pathlib provides platform-independent path operations. Chunk processing prevents memory issues with large files. Input validation prevents data corruption. Proper encoding handling prevents character issues. We've covered the essential aspects of Python I/O operations. Understanding these concepts allows you to create programs that can effectively interact with files, handle user input, and manage data persistence. Remember to always handle errors appropriately and follow best practices for reliable and maintainable code. Practice these concepts by working with different file types and creating programs that process real data.